Okay, well, welcome back. We got another video on solving equations. And you go, well, wait a minute. Did we just do that? Yeah, with some pretty important operations with addition and subtraction. Today we're going to, well, this lesson, hopefully the same day for you, we're going to focus on how to solve equations with multiplication and division. Now, we're not going to spend a whole lot of time going through our goals. It's the same goal. Your goal is still isolate the variable, get it by itself. We learned last time in the last video that we got these things called equations. We put our little line there saying you got both sides, and you can do whatever you want as long as you're following these two things here. Do whatever you want as long as what you're doing to both sides and you're undoing the given operation. So we've been chugging along. You've probably done some work on equations that involve addition and subtraction at this point. And then we get to this one. You go, all right. Equation? No. Expression. What's going on here? Well, you got 3 next to a y. If you're not familiar with it, if it's been a little while, it's okay. When a number is right next to something, or a variable is right next to something, like 3 next to a y, or 3 next to a parentheses, there's always an implied, do you know it? Do you know what's there? There's always an implied multiplication. So 3y means 3 times y. 3 parentheses means 3 times parentheses. So we got this expression here that goes, well, 3y, can I solve it? No. Can I solve it? Sure. Could you do it in your head? Probably, if you understand it. Let's look at it real careful. We got an equation because we have an equal sign. There's 2 sides. We have a left side, we got a right side. Put your pencil on the variable right now. Now, you know what I'm going to ask you, hopefully, because I've been kind of prefacing this a lot with everything. Is your variable isolated? That's our main goal. Is your variable isolated? What I want, maybe write down the goal. Show your sides. Show what you want. I want my variable, wherever it's at, keep it on the same side if you want to, it doesn't really matter. I want my variable on one side of the equation all by itself, nothing around it. So we look back here and we go, yeah, we had an equation, yeah, we've got 2 sides, yeah, we have, our variable on it by itself. What's going on with that? What's the 3 doing? We just talked about it. Well, it's being multiplied. Well, we haven't dealt with that before. What's the opposite? What's the inverse of multiplication? Can I still do this? You know what? The answer is yeah, you can. You literally can. But is it going to help you? Is it going to get the y by itself? And the answer to that question is no. But why? Why doesn't subtraction help you here? Would it help you if I did that? Sure it would. Because you have 3 plus y. Oh, yeah, for addition and subtraction, I use addition and subtraction. What do you think I use for multiplication? Well, we learned this a long time ago when we started learning our operations, is that there's a couple of them that pair up, multiplication with division, just like addition to subtraction. So when we see multiplication, let's use division. Let's undo this. Now how we show that, we go, well, 3 times y. What's the opposite of, or the inverse of 3 times? Let's do divide. Let's divide by 3. Now the big things come in here. What we do to one side, you gotta do to your other side. It's necessary. You have to do it. Miss that thing, you miss the idea of solving equations. You get your teeter-totter. What you do to one side, you do the other. You keep it even. You have to do that. Now, the bigger idea. Why does it work? Why in the world? Why do we want to divide by 3 here? Because what's 3 divided by 3? What do you get when you divide 3 by 3? Well, 3 divided by 3 gives you a big fat 1. Well, wait a minute. Won't 1 times y give you something? Oh, crap, it won't, huh? Because one's a great number to multiply. Oh, goodness. We don't want zeros. Imagine that. Imagine if we actually took this and subtracted 3. Imagine if you could actually do it, okay? So 3 minus 3 would give you 0. 0 was great when you were adding y, because 0 times the number gives you back the number, the additive identity. 0 plus y gives you back y. But what happens when you multiply by 0? That's the big question here. This is the reason why we can't use subtraction. 0 times y? Hey, 0 times anything gives you 0. That's a problem. Because if we're using subtraction to fix multiplication to undo that, you're always going to get 0. But wait a minute, if you're always going to get 0, you'll never ever be able to end with your variable. You'd get 0 on both sides of your equation, and every single problem would end with 0 equals 0. That's true, but it's true because it's wrong. We're using the wrong technique here. That's why we can't subtract. First, it's not the inverse of multiplication. Secondly, even if we allow it to happen, you'd always be getting 0. And 0 times your variable would give you 0, not your variable. If that doesn't make sense, watch that again, see if you can stick with it. The reason why we can't subtract is because, from multiplication, is because when we multiply by 0, which is what addition subtraction would give us, you'd always get 0. What we're looking for is, can you think about it? What are we looking for? What do we want? What can you multiply by that gives you back the same number every time? So like 5 times what gives you 5? 9 times what gives you 9? Y times what gives you y? It's only one number you can multiply by that gives you back what you started with. It's called the multiplicative identity, and it's 1. We can always multiply by 1. So don't miss it. Here's what we want. For addition subtraction, we're trying to get 0 for addition subtraction. For multiplication and division, we're trying to get 1. Variable plus and minus 0 gives you back variable. Variable multiplied or divided by 1 gives you back variable. That's what we want here. So how can we get a 1? 3 times y. 3 divided by 3 gives us 1. 1 times y is where we get our y. That's what we're looking for. This creates our 1 for us. What we do to one side, we do to the other. Notice how I'm showing my operation. I'm not just leaving a 3 hanging out there because it gets really confused with addition or subtraction. I want to show what I'm doing. Show what you're doing. Show whether you're adding, subtracting, or in this case, dividing. So we had an equation. We saw 3 times y. We said, I want my y by itself. I want to undo what's around it. Subtraction doesn't do it. We talked about it for a long time right now. Division would. Division is the inverse for multiplication. It gives us a 1. That's great news because 1 times y gives us y. On the right-hand side, hey, 15 divided by 3, we can do that. You get 5. Probably what popped into your head when you first saw the problem, but we could check it. 3 times 5 gives us 15. We're good. We know what we're doing on that one. Let's practice just a couple more. Just 2 with multiplication. We'll talk about division and we'll be good to go. This is a big one. This is one, man, if I give this on a test and people really don't know what they're doing, I'm going to see a lot of this mistake. Check this out. Let's say you're getting on a test level and you're looking at that and you go, man, it's an equation. I can solve that. I got 2 sides. I know my variable's right there. I'm going to get rid of that -4. Leonard told me in the last video, I just add 4 to both sides. Boom, mic drop, I'm done. What do you think? Is that the right thing to do? Part of learning math is being able to find someone else's mistakes. It's just a great way to do that. Why your teacher, if they do any sort of think, pair, share, I do this a lot, where I'll have students at this level do something, then look at each other's papers, and if they have different answers, you kind of go, why? And you talk about it in class and discuss why you got different answers and figure out what went wrong. Finding someone's mistake is really important. Can you find a mistake here? Why is it a mistake here? Does addition get rid of how it's connected? Well, let's think about it. When we see our equation, that says -4x. Anytime you have a number next to a variable or parentheses, it means, think about it in your head, it means multiplication. Is addition going to get rid of multiplication? Is subtraction going to get rid of multiplication? What if it did? What if we let it? If you added 4, what's -4 plus 4? Sure, it's 0. What's 0 times x? 0 times anything is going to give you 0. You'd essentially, if you let this happen, you can't even do it, but if you let that happen, you'd get 0. You'd eliminate your x. We don't want to do that. What we want to do, no matter what, is undo the given operation. So if we have -4 times x, let's divide. Now, here's the big deal. We're not trying to get 0. So we're not going to be using a different sign or opposite sign. That's kind of how addition subtraction worked. When you had addition, you used subtraction. The sign was different. Here, I'm not trying to get 0. I'm trying to get 1. Positive 1. Positive 1's the only number that lets us multiply and get back what we want, get back what we have, get back our variable. So if I divide by positive 4, it's probably negative 4 divided by positive 4 is not 1. It's negative 1. When we're dividing, we're going to be dividing by, it made sense here, we're going to be dividing by exactly the same number, because dividing by exactly the same number is the only way that we actually get 1. So notice something, don't move on until this makes sense to you. We have an equation, yes. We have a variable here, cool. It's connected by multiplication, we're identifying that. When I identify that I need to get rid of multiplication, I'm immediately thinking division, I'm immediately thinking I'm trying to get 1, and I'm doing whatever it takes to get 1. When we're dividing, you need to divide a number by itself, exactly itself, to get 1. The other side, like we talked about, it just plays along. It doesn't even matter what this is, you're going to be dividing by negative 4. Notice this, I'm showing my division. I don't want you doing this. Please don't do this. Please don't do that. When we start doing that, that looks like subtract 4 to pretty much everybody. So show what's going on. You can do divide if you really want to. That's fine too. I don't care. As long as you show what's going on. Right now we're showing that we're dividing by negative 4, not subtracting negative 4. That's a big deal. Our signs are the same here because what we do to one side we do to the other. Now we run through it. Hey, what's negative 4 divided by negative 4? Awesome. 1 times anything, you can even cross it out if you want to, gives you back your anything, gives you back your x. Negative 4 divided by negative 4 is 1. 1 times x, we get x. On the right-hand side, well, calculator, do it in your head. Remember though, we've just switched rules. We're not adding, subtracting anymore, we're multiplying, dividing. Which means if your signs are different, no matter what, with multiplication division, if your signs are different, you're going to get a negative answer. We get negative 7. Don't go any further before you check the book. Negative 4 times negative 7 gives you positive 28. We know that we're right. Real quickie here. Hey, we got ourselves an equation. We know that the equal sign gives us 2 sides. We're going to identify our variable. Try it on your own if you want to. Pause it or skip forward a little bit. That's fine. Try that one on your own, though. See if you can do it in your head. Write it down real quick. Put your pencil on your variable. Right-hand side. Look how they're connected. That's a big deal. If you're going to undo the given operation, you need to identify the given operation. They're connected over here where my variable is. It's not isolated. This is connected by multiplication. Let's undo that multiplication. Division is the only thing in the world that undoes multiplication. What do you think? Did you divide by positive 13 or negative 13? With division, you're trying to get 1. In order to divide and get 1, you need exactly the same number. And with equations, you do one side what you do to the other. Negative 26 divided by, I've shown my division. I've used the same number. I'm using division because we were given multiplication. And I'm trying to get positive 1 here. Negative 26 divided by negative 13, that's, well, negative divided by negative. If you divide or multiply with the same signs, you're always going to get a positive number. You're going to get positive 2 here. On the right-hand side, let's work through this. Don't take it for granted. Look at what it does. Negative 13 divided by negative 13. You want to try that on a calculator, that's fine. You're going to get positive 1. That's great because positive 1 times y is going to give you back y. We just get y equals 2. And you know what? It works. Negative 13 times 2, checking this in our original equation, gives us negative 26. Bam, you got that. We're going to move on real quick and talk about division. In order to really grasp division, you really need to get the multiplication first. So if that doesn't make sense, don't move on. Don't move on yet. Watch this again if you have to. Try these examples on your own until they really work. Check out your textbook if you have one, if you need to. But the idea is you're not dealing with addition, subtraction. You're multiplication, division. With multiplication and division, if we have multiplication, you are going to need to use division, not addition or subtraction. When we're dividing, you're trying to get positive 1 divided by the same number. Now we switch gears. We talk about division a little bit. So 1/3 y. Crap, that looks like a fraction. Looks like multiplication. That's not division. fractions are division. Fractions are created by division. So when we have like 1/3 y equals 7, yeah, we got an equation. You know what? It even has two sides. We know where our variable's at. We got one right there. Now, that to me looks like it's connected by multiplication. So we get a choice. You can undo this. It actually works. If you want to look at this multiplication-wise and divide by 1/3, you totally can do that. But then you got to know a little bit about fractions. It'll work. It'll work. Let's make it a little easier. Instead of thinking about this as a fraction, there's always something you can do whenever you have a fraction next to a variable. This will work all the time. Just let your variable float to the numerator. You see 1/3 times y, which is exactly what you have, is the same thing as 1/3 times y over 1. This is where your knowledge of fractions comes in. If you multiply fractions, you don't need a common denominator. You just multiply straight across. 1 times y is y. 3 times 1 is 3. You can always do that, which means that you can always move your variable to the numerator of your fraction, no matter what's up there. That's kind of cool. Why it's cool is because it lets us look at our fraction a little bit differently. Instead of 1/3 times y, now we can think about it as y divided by 3. Stop for a moment, just focus here for a bit. If you have 1/3 of something, cut it in thirds. Cut it in 3 equal parts. If you take something and divide it by 3, you're cutting it into 3 equal parts. They mean the same thing. 1/3 y and y divided by 3, identical. We're just choosing to look at it this way because instead of dealing with multiplication of fractions, you're now just dealing with y divided by 3. Fractions are division. Now, it makes sense to me if well, hopefully it makes sense to you. If you undo multiplication with division, we should be using multiplication to undo division. Now, how's it work? Because before we were trying to get 1, so let's look at that for a second. What is the opposite of y divided by 3? How would you get rid of this idea of divide by 3? Well, the opposite of that would be, or the inverse of that would be, makes sense, multiply by 3. Let's see why that works. So if we multiply both sides by 3, remember, both sides, what you do to one side, you have to do to the other side. All we've done is taken our y, moved to the numerator. We have y divided by 3. Hey, the opposite of y divided by 3 is times 3. Let's multiply by 3. Is multiplying by 3 the inverse of divide by 3? So it's got to work. Why it works is important, though. I want you to look at it for a second. Don't go through a math class without knowing exactly what's going on. That's a real poor way to learn math, because what's going to happen is eventually you're going to go, I don't know what's going on. I'm just following steps here. You're not going to be able to proceed very far doing that. Why this works is because if you multiply by 3, you can always write any whole number as a number over 1. We actually just did that with our y. If you multiply fractions, we'd get 3 times y over 1 times 3. Multiplication is commutative. It means you can switch them around. But then, wait a minute. If we can multiply 2 fractions together, we can also split 2 fractions apart. That's interesting. What's 3 divided by 3? Well, crap, it's 1. That's exactly what we're doing here. We're just getting 1 in kind of a fancy way. So we get 1 times y over 1. 1 times y gives you, well, actually, let's do 1 divided by y. 1 divided by y gives you 1. No, it doesn't. It gives you y. 1 times y gives you back the y. So essentially, we're just getting a real big fat 1 there. That's what we're getting. 1 times y, oh, that's a beautiful thing. With addition, subtraction, you're trying to get 0. With multiplication, division, you're trying to get 1, because 1 multiplied by your variable is going to give you back your variable. Y divided by 3 times 3 gives us 1 in kind of a roundabout way, but it still gives us 1 times our variable. That's a big deal. On the right-hand side, man, it's just playing along. 7 times 3, you get 21, and you can check it. 1/3 times 21, try it in your little calculator, or do it in your head. Or 21 divided by 3, either way you're going to get 7. That's the correct answer. But this is important. This is why it works. Follow that through a couple times. See if you can actually write that out. See if you understand that when you multiply by 3 here, you're creating something that allows you to make one fraction, that allows you to get a numerator the same as a denominator, which creates 1 times what you really wanted. Your variable on that cell. That's a great thing. Tell you what I want you to do. What I'd like you to do is follow me with one more example. We're going to see kind of a combo idea here, and then try one on your own. So we got that guy. It's clearly an equation. We have 2 sides. We got our variable. If I put my pencil on my variable, I got one right there. It's clearly not isolated. I want x all by itself. Right now I have 4/3. What's there? Addition, subtraction, multiplication, division. What's there? Right now, we'd have multiplication. Right now we have multiplication. So we want to get rid of this multiplication. There's 2 ways to look at it. We can either divide both sides by 4/3. You're going to have to deal with fractions, but you can do it. Or, I wasn't lying to you before, move your variable to your numerator. For the same reason explained over here, you can watch that again. You'd have 4/3 times x over 1. 4 times x gives you 4x. 3 times 1 still gives you 3. And we get equals 8. This is kind of a combo move, though. So what are you supposed to do here? Well, how would you, let's ignore this for a second, the 4x. How would you get rid of divide by 3? See that one? If you got rid of divide by 3, well, we should be multiplying. Multiplication is the inverse of division. If we do that on both sides, we've done the same thing to both sides. It's going to be equal here. Multiplying to get rid of division is going to create a 1. So you can follow this again. We're doing the same thing. You're being able to put these on the same fraction, organizing 3 over 3, splitting it back up. This is going to create 1 for you. 3 divided by 3 is 1. 1 times 4x, whoa, wait a minute. 24, cool. That's still 4x. But now we go back to multiplication. This is why we had to understand multiplication to do this particular technique. You still have 4 times x. How are you going to get rid of the 4 times x? Are you going to add, subtract, multiply, divide? Well, look at it. How is that connected? If it's connected with addition, you'd use subtraction. Subtraction, you'd use addition. Multiplication, we're going to be using division. If we divide 4x by 4, we're going to get a 4 divided by 4 is 1. 1 times x is x. The other side just plays along. We get 6, and we're done. Now, there is another technique that's a little bit more advanced, but it's quicker. You can do it here, or you can do it here. Because the nature is you'd be dividing by 4 eventually, and you'd be multiplying by 3 eventually, you can do it at the same time. It looks a little weird, but a lot of people will teach it this way, and this is not a problem. If you have fraction times a variable, or even variable inside of a fraction, you can choose to multiply by the reciprocal, because what a reciprocal does, it puts a denominator on a numerator. Oh wait, that's multiplication of the denominator. It puts a numerator on the denominator. Oh wait, that's division of the numerator. It's basically these 2 steps wrapped up into one. As long as you do it to both sides, reciprocal on both sides, the 3 divided by 3 and 4 divided by 4 still work out. 3 divided by 3, that's a 1. Times 4 divided by 4, that's another 1. Times our x, we still have our x, but now it's 1 times x. Remember, multiplication division, you're getting 1s. On the right-hand side, 8 times 4/3, you can simplify that fraction, you can use your calculator, but I do it this way. We'd still get 6. Same answer, a little bit less work, but it takes a little bit more to get there. Either way you want to go on that one. Now I'm going to give you one you can try on your own. I'd recommend you pause it, see if you can do this example on your own. I'm, of course, going to go right to it, so that's kind of up to you. So we deal with negative 3 equals negative 9/5 x. I'm going to model my thinking on this one. You should have already tried this on your own. So firstly, I'm looking at, do I have an equation? Yeah, of course I do. Got an equal sign, got an equation. That means we can solve it. Find out the one answer. Now, as we're digging back a little bit, but that's got a power of 1. There's going to be one answer here, one solution. Finding that one solution makes a true statement. So I have my equation. That means I've got two sides. I also identify where my variable's at. So I got my variable x, just one variable on the right-hand side, but it's not by itself. It's not isolated. I want that by itself. So how we're going to get it by itself? Let's look how it's connected. This is connected by multiplication. But wait a minute, I got a fraction. Crap, I don't want to deal with a fraction. I could right now multiply by the reciprocal. Now, a lot of teachers are going to throw that, just multiply by the reciprocal. Why? Because I freaking told you so. Okay, that's not the idea here. The reason why this works is because of how I showed you. This is why it works. The reciprocal idea is kind of a shortcut, which is fine. But the reason why is because you're dividing and you're multiplying by appropriate numbers here. That's why. You're creating ones. 1 times variable gives you back a variable. That's why. Know that, okay? So I can choose to multiply by the reciprocal, not because it's a neat trick, but because it actually works with both these techniques at once. Or I could choose to move my variable to the numerator. Also, I want you to look at this. If you have a negative, take that negative and move it to your numerator as well, okay? Take your variable to the numerator, take your negative and move it to the numerator. So I'd be thinking about this as negative 9x divided by 5. Why? Why would I think about that? If I'm not super clear on the reciprocal, it's because it breaks it into 2 operations, which is much less intimidating than just a big fraction that we don't know what to do with. Because you're not going to be subtracting that fraction. You're not going to be adding that fraction. Now's a good time for you to think about why adding here would suck. If you add here, you'd be creating a 0. 0 times a variable gives you 0. That's bad. It's bad news. I don't want to do that. So we cannot add here. We do have to either divide at some point and multiply at some point. But by creating this negative at the numerator, variable at the numerator, you let yourself look at this in 2 different fashions. Firstly, you have a division problem. Let's take care of the division problem by multiplying by 5. I'm showing my work. You might also choose to put this in parentheses to solidify that as a negative 3 and not accidentally do 5 minus 3. So this is 5 times negative 3 here. That gives us a negative 15. On the right-hand side, hey, look, we have a divide by 5 times by 5. That's a 1. 1 times negative 9x gives us back that negative 9x. That's fantastic, because now we're back in multiplication land. With multiplication land, I know that all we're really doing is looking at our 2 sides and undoing multiplication, not by addition. You don't want to do that. We talked about it many times. Adding here would create 0. If you even let that happen, it's not even possible. But if you let that happen, you'd have 0 times x. The only thing that gets rid of multiplication is division. We're looking for ones. The only way to get 1 is dividing a number by itself. Do that on both sides. Negative 9 divided by negative 9 is positive 1. Positive 1 times x, that's what we have here. It's that multiplication. We're just getting rid of the number that's being multiplied by x. Gives us positive x. The left-hand side plays along identically. You divide it by negative 9, divide by negative 9. You know your calculator actually works here pretty well. You should have a fraction button on it, like an ABC, or it has a boxed little line, looks like this. Or looks like that. Press negative 15, not minus 15, negative 15. Press your fraction, press negative 9, press equals. It will automatically simplify your fraction for you. Sometimes it'll put it in mixed number form. That's fine. Most of the time we leave it as an improper fraction, but that's okay. So if you have that calculator used to your advantage, negative divided by negative is a positive. 15 and 9 both have a common factor of 3. So divide both those numbers by 3, all right? Or negative 3 if you want to do it at the same time. You're going to get a positive. You're also going to get 15 divided by 3 is 5, and 9 divided by 3 is 3. Your correct answer here is 5/3. your calculator might have given you 1 2/3. That's okay also. Either one of those works. Most people probably just can leave it as 5/3. Easier to check your work that way. So now what you should have got out of this is that addition, subtraction, and multiplication, division work differently. With addition, subtraction, you are trying to get zeros. With multiplication, division, you're trying to get positive ones. If you keep that in mind when you see your equations, you're much better off. I hope that's helped you. Next time, we're going to start talking about a little bit more advanced equations here, but you're off to a good start. Practice this stuff.